Hello, am I audible?
Yeah.
Yeah.
Yeah, so let's start with the meeting. So my screen is visible, right?
Yes.
Yep.
Okay, so I will talk. There is a echo somewhere. Yeah. So we are doing some settings, just waiting for that. Okay. Okay. So we can start. Hello, everyone. So welcome to DevDay. We do this almost every month, or maybe even more than. We might have more than one talk per month. So this is our attempt to share back with the community. And DevDay actually happens in every, basically 3 places, at least from in India. DevDay Bangalore, Pune, and Chennai. Okay, so yeah, let me talk about what we are going to say in the today's session. Okay, so today we are talking about the decomposition of the monolithic code base, and what are the design principles that we can use to actually approach some of these things. So before we start, I will quickly talk about who I am and my introduction essentially. So I am Prashant Kalkar. I have taken certain talks on the DevDay previously as well. So you might have seen my previous talks on the same platform. Okay, there is some disturbance. Okay, so I'm with Sahaj for maybe I think 3 or 4 years now, working on various parts of the applications, including development, architecture, the DevOps side of things, infrastructure automation, and whatever else that is required to do the delivery end to end. Okay, so that's my role. And I primarily worked on the JVM stack mainly. So that's my experience. Okay, so let's start with the today's talk. So let me know if my screen is still visible. I just changed some settings. Is it still visible?
Yes, we can see Uncle Bob's website.
And you can see the slides, right?
Yep.
Okay. Yeah. So let's talk about the agenda that we are going to cover today. Okay. So mainly we will talk about the modules, as you might already know. So the focus of this talk mainly is around that why we want to consider anything around the modules, why possibly the modules can help in managing a bigger code base, a monolithic code base. And then we will talk about modules, or how the reusable code should look like overall. So we will talk about reusability and how will you approach the module boundaries, and those are important things because that will actually basically make your life. Okay. Yeah, so we will cover the package principles. They are divided into basically principles of the cohesion and the coupling. So we will not cover everything in depth, but we'll try to see how can we use it for the goal that we have put in to essentially come up with the modular approach to break up the monolithic code base. And the last part is mainly about are there any tools or anything that we can use, any techniques that we can use to break up the code base. Okay, so let's start with the question that how modules can actually help in terms of so even if you do the you convert your code base in a modular term, why will it actually help you to deal with the maintainability of your system? Okay, so there is a term that we generally use called big ball of mud, and that term is actually mainly talking about a code base where there is not much of a structure. Okay, so everything is coupled with everything else in the code base, and anything can call anything in a way. So this diagram, so I have taken this from the book Building Evolutionary Architecture. So you can see that see this diagram is created as a visual representation of all the coupling between the classes that are there. Okay. Generally, our code base is not this bad because we use some structure like layered architecture and all that. But this is just a depiction of the coupling that you can have in a in a monolithic code base, because there is no one essentially stopping you from creating this kind of a coupling. Okay, so let's see how actually your modules can help reduce this thing. So what module can actually do is, so even if I break up this code base into two modules, let's say, so then in a way, any modular system that you have will generally disallow you to do a bidirectional dependence. And what happens is now one part of your code base now can use the other part, but the entire other thing, basically module 2, depending on module 1, is now disallowed. Your code won't compile in a general sense that if you are using this kind of thing. So because doing this compartment, so those two code bases might still have issues. There are still couplings in them. The code might not still be completely clean and all those things, but you have reduced some coupling between these two just by moving out some code. At least that part of the code can't have coupling in the other parts of the system. So that is reduced, and because that is reduced, the internals coupling or internal calls are still there, but the external things can't be used. So I cannot actually add a call from my modules to the main code. Okay, so that is at least prevention. Okay, so I need to clarify that when I'm talking about modules here, what exactly I'm talking about. So in general, the modules that we talk about are essentially the jars or the compile time dependencies that you basically use. So any modular system in that. But I have reduced the scope of the module as a term here, at least in this context, that what I'm talking about is I'm talking about in repo modules. So I'm not talking about creating a completely general jar or var or some library that is used across the organization. I'm not talking about that. I'm talking about a very specific, it will still be a jar in case of Java or some other languages. It will still be a module, but it will be within a repo. So I'm talking about very specific term here. And why am I talking about that is, so probably doing in repo module is the first step. You can essentially evolve it to be a library that will be used much widely across projects. but this is probably the first step that you will get and still get the benefit or reap the benefit of this. And also the other benefit is, because you are not you are still doing it in repo, the usage is within the repo of that module. That means you can choose to alter the definition or the content of the module. You can choose to basically change the boundaries of the module and say that you might not get the boundaries right the first time, but because you are doing it within the same repo, you can essentially change the content of the modules. So I'm essentially talking about the multi-module project here. Okay, so let's talk about the reusable modules or reusable code and why it becomes difficult quickly once you try to actually have a reusable code base. So in this case, what do I have here is I have a reusable code called R. So that's a module that I have, and there are two users of those, A and B. So module A and module B is actually trying to use that reusable module. So they have basically both of them are using the reusable module R. Now the thing is, for any changes for R, the changes can come from the module A, because they basically are using the module and they will start asking for a feature or a change or any changes, any bugs, anything. They will start asking for the changes in the module, in the reusable module. Same will happen for the other clients. So basically changes from B will also come in. So, and if you have more of these, you will essentially end up having a lot more possibility of changes that are being asked on these modules. Okay, so reusable module has more reasons to change. Okay, but at the same time, because we are basically doing we are trying to reuse that module, we want it to be highly stable. You don't want to use something that is changing every time, all the time. And then every time something changes there, what will happen is they might actually introduce a bug, or something that was previously working is not working anymore. Or at least bare minimum, even if they are doing everything right, I still need to go and update my code to the newer versions or retest the whole thing. And all those things are there. Okay. So what we are doing here is the reusable code has this kind of a opposing requirement, that there are more reasons for it to change because more people are actually using it. But at the same time, we don't want it to change that much so that we can rely on the stability of the reusable code base, so or the reusable module. So that's the opposing requirement that you essentially get for any code that is reusable. Another issue that might happen in this case is, so any change that you do in case of the reusable code, if you are done it for a particular client in terms of the requirement, you might end up actually breaking the other client. So in a way, reusable code or the module is actually a coupling point between these two things. So you have to get you have to have some way of satisfying this opposing requirement. So we will actually see that how can we try to manage this. Okay. So let's talk about the module boundaries. That might actually give us some hints in terms of what goes inside the module. And once you understand that, then we can say that, can we come up with a module or a system that allows us to capture the opposing requirements. Okay. So what you have here is a simple three classes, to be honest. One is a client code that is trying to use a class called switch, which is just calling a class called light, and it is calling a method called turn on. Okay. So if you visualize the code here, the switch is essentially has an object of light, and it's calling the turn on method on this. Okay. So right now switch is very specific in terms of implementation with the light. Anything else that comes in is essentially a problem. Okay, so how will you try to solve this? What will be the approach that you can take that will allow us to also? So right now switch is very specific to light. We have an object directly in the switch. Even if it is injected, it is still very specific to the light. Okay, so what we can do is to essentially also incorporate a fan. So we can actually we can actually introduce an interface. So a lot of us will actually do this. We will go ahead and say that, okay, this coupling doesn't really look correct, and this is preventing me from introducing or using the switch endpoints for essentially something else like fan. Okay, so you will essentially go ahead and use the interface as part of it. But what are the boundaries here? Is there any module that are there? But this is where, so we do this correct, okay, most of the time, but we don't think about the boundaries. Where do I actually make a cut? So if I need to release a switch as a library or as a module, what is the components that I include in the can you go on mute? Yeah. So what are the things that will actually include in the module? So let's see some options that we have. Okay, one simple option is the entire thing is a module. Okay, simple as that. You say that, okay, this is my library. These are two implementations that are there. I have a switch. You can essentially call this and use this, and everything is great. Okay, so option one is there. Then there is this option that I basically just package this switch, and everything else, all the implementations of the interfaces are separate. They might be separate in their own terms, or they might be packaged as well together. So you turn this on in this. So any comments on these two first? There is one more option that I will show. But before we move ahead, any comments on these or this one? So option one is quite simple, quite straightforward. So option one, any comments on option one? Any comments on option two? Anything that you think is maybe right, wrong, pros, cons, anything? Okay, let me also talk about the option three. Okay, so this is the third option in which we are saying that there is a switch, the interface is with the switch, and then there are light and fans that are the implementation. So the code is still the same, we just put in the boundaries essentially. So three types of things. Which one do you think makes more sense or have effects in terms of having a good reusable module in this case?
I think I will prefer this third one. The sole reason being, since the light and fan are two independent modules, client can choose which one to bring into couple with.
Okay, so he's saying that third one probably will allow you to bring in the implementations for the interface. Okay. What about option two? You can bring in there as well, right?
So if we have to add an appliance, then the whole module has to be redeployed and the client has to then use the same module.
Okay. So in case of all three options, you have an interface in place. Okay. That means you can always add a extra implementation of that interface. Okay, but just choosing a particular boundaries of this thing, let's see what is the impact of a change that is happening on the clients as well as mainly on the clients and the component themselves. Okay, so if you see all three options and let's see how the changes will affect the clients themselves. Okay, so if your change happened in the switch or interface or the interface, essentially, in this case, all your clients are affected because they are directly using the switch as a module. So even if you have option 1, everything is together anyway, you are going to be affected because of that. Option 2, again, because you are using the switch, you are going to be affected, and option 3. So all 3 are same in this regard. In case of the implementation changes, like a light change in the light, option 1 is packaged, light is packaged with the same option. So you are going to be affected because of it. In option 2, we are essentially, so if you see the option 2, the light is here, the switch is dependent on the light and the interface and everything. So if I change the light, then my switch is going to change, my client is also going to change. Okay, because I'm essentially using the light. Okay, so in this case, option 2, the switch and the clients will basically be changing. Okay. In case of option 3, however, if you see the option 3, we only need, so in case of changes in the light, we only need the clients that are actually affected are only the one that are using the light, no one else. And also there is no need of a change in the switch as well. Okay, so because switch is completely independent of the light. Okay, so you can see that dependencies are actually going from light to the switch component, not the other way around. So switch does not even know that there is a light that exists. It might, something else completely can exist. So we don't need to know that what exists, what are the implementation of those things. Okay, so switch is completely unchanged in case of changes in the light. Similarly, the clients which are not using light does not need to actually change anything. So if I have a client that just uses a fan and not the light, then I don't need to worry about changes in light. Okay. Similarly, if changes in the fan on the option 3, so option 2 and 1 are same. Option 1 and option 2, those things will actually affect, the changes in the fan will affect every client. But in case of option 3, only those clients will be affected which are actually using fan, which makes sense. So because the implementation is changing and I am using the implementation, I will be affected. The good thing here is if I don't use a particular implementation, I don't get affected. And that's a good thing, because then I don't need to worry about changes in a light that I am not even using. Okay. So in this case, what we have essentially done is we are saying that your interface gave us a boundary in a way that allows us to say that, okay, anything that are the implementation of these interfaces are outside of the module boundaries. Okay, so and it is important to actually get this right. So even if you have an interface, the presence of an interface does not directly guarantees that your boundaries are correct. So for example, if I have so in this case there are light and fan, but let's say I just have a light. So if you actually go with this, so you have an interface and a light, even if it is a logical module, you might end up with an interface called abstract light. Okay, so if you end up with an interface that called abstract light, in your mind you are essentially saying that this interface and the implementation is together. Okay, if the interface and implementation is together, then you, even if in the presence of an interface, the interface is actually changing with the implementation. So every time you do a implementation change, if that particular method is not accessible from the interface, you will end up adding it into the interface, and that means you have essentially affected everything down, whoever is actually using it. So having a interface in itself is not enough. You have to also think that where my boundaries lies. Okay, and that's the only. So in this case also, if you see, if you talk about dependency inversion principle, the DIP, In this case, which switch is actually still dependent on the implementation. So dependency direction is actually from switch to the fans or to the light. Okay. But in case of the option 3, the dependency direction is from light to the switch. Okay. So now dependency direction is essentially inverted. So unless the structure is same, all number of classes and everything is same. But in this case, you haven't achieved the dependency inversion because of the compartments that you are creating. In this case, however, you are essentially saying that, okay, my switch is now independent of light, and light depends on the switch, not the other way around. In this case, the switch was dependent on the light. So inversion of the dependencies has happened. Okay, let's move on. So one more example in which I have added more clients just to clarify that what is actually happening. So in this case, again, I have something called as a checkout module that is doing tons of things. So something like a receipt generation, maybe tax calculations, auditing, and payments, essentially actual payment. Okay, and let's say that right now it is just doing a cash payments. So in this case, if I end up with a new client that says that I also want to support card payments, okay. So how will you approach this? What will allow you to get the boundaries right in a way that you will continue to be able to use the payment method that will basically allow us to satisfy the opposing requirements of the reusable code. Okay, what can be the approach for this? What can we do about supporting the card payments? So in this case, what happens is, again, in real life, you might have the implementation as part of this module or a logical module, or you might have a dependency on a payment, cash payment. So it might be a dependency as well, or it might be a code that you have yourself. In both the cases, the dependency direction is from the module on the implementation. Okay, so in a way, from a usage point of view, I'm using everything together. Okay. So in this case, what we can do is essentially something like this. Okay, so what we did is, instead of directly depending on a specific implementation of the payment, we said that we will actually not worry about the specific implementation. And where my boundary ends is where the interface is. Anything beyond that is outside of my boundary. So I don't need, I should not actually change because of the changes in the implementation. So that way, now I can implement a new thing called card payments. And that card payment is now dependent on the modules, not the other way around. So because I created an interface, two things I did. I created the interface, and I also made sure that interface is made part of the module. So now, because the interface is part of the module, my dependencies is that my implementation depends on the module, not the other way around. So that means, what is the benefit of this? Any future changes that comes in for the new payment types, I don't need to actually make any change in my reusable module. Okay. So if something new comes in, like a UPI implementation or something like that, I don't actually need to change anything in my checkout module at all, because all I need to do is add a new implementation of the interface and take care of the implementation as part of it. And whoever clients needs a specific implementation, they will just choose a specific implementation. They are not worried about every other implementation that exists. So you are actually coupling to only the part that you are actually using, and not more and not less. Surprisingly, this also allowed us to add a new requirement. So I essentially added a new thing like a UPI payment while not actually making any change in my module. So in a way, that opposing requirement that we were talking about at the start, in a way that is kind of achieved. Okay, so we didn't make any changes for the UPI in the checkout module, but we still were able to support that. Okay, so let's talk about the principles that we kind of used or touched upon in this two examples. Essentially, we also did dependency inversion, but I'm just focusing on these two right now. As part of applying these two, we also did a inversion of the dependency, because now my implementation depends on the abstraction rather than the other way around. And that is a powerful thing, because now I don't need to actually change the abstraction. Okay, so in case of a why do we need to actually talk about the ISP? There is one specific thing that the ISP actually talks about, is to have a segregated interface. That means my interface is created from a point of view of the user of the interface. So in our examples, maybe the checkout example, the switch example, the user of the interface is actually switch. Okay, that means whatever is required for the switch is the only thing that exists in that interface. So my light might also have some more methods in it, or my fan might have a regulator that actually allows me to increase this fan speed. But I don't need to include that in my interface, because my interface is coupled with, or is maintained with the usage, with the user or the client of the interface. In this case, the user of the interface is the switch. So whatever is required from a point of view of switch, those are the only thing I'm adding in that interface. So that's how you end up with a segregated interface, interface that is focused for a client, not from a point of view of implementation. So in this case, if this is your compartment, it is very difficult for you to actually name it something like an abstract class or an abstract account or something like that, because account or a abstract light or something like that does not even exist in this boundary. Those are eventual implementation that we don't even know that they actually exist or not. Right now, our focus is to just say that, okay, this is my boundary, and there will some implementation that will do this for me. Okay, so this only includes what is required from a point of view of the module and nothing more than that. And that's how you end up with a interface, segregated interface. So your implementation might include a number of more things, but you don't need to include that in your interfaces. The same thing goes in that payment interface. Essentially, whatever I'm going to use as in that module is the only thing I need to add in that modules. Anything else extra is not visible. So I'm only coupled to those parts which I care about, not more than that. Is there a question?
So I see a couple of issues. First thing is, there's nothing stopping card payment model to use the receipt generation code.
Card payment modules?
I use the receipt generation code because it has a
Uh-huh. Yes.
There's no compile time restriction that stop.
See, the card payment is using the receipt. Is that what you're saying?
Yeah. Because
okay.
It has that access.
Yes. Yes, it has that access. But the other way around is not possible.
Yeah, but
so receipt cannot use the card payment thing.
Right.
Yes.
But yeah, but ideally card payment should not use the receipt generation code, but it has the access.
Yes.
And secondly, suppose I have a monolith microservices application where I want to use the card payment model.
Mm-hmm.
Now that if I have to reuse between two microservices, I cannot use card payment unless I have dependency on the checkout.
Yes. So checkout module, see, card payment is the implementation of a checkout module. Okay, that's where the main code is. That is same across all the implementations. Are you getting?
What I'm thinking is maybe my same card payment, but they have an option for where we take out payment interface as well as
Checkout payment interface. Yes. Yes, that is possible. Yes. So
if I just want card payment across different microservices, I did not depend on checkout model.
so complete decoupling is also possible. Yes. So okay, in real life, okay, you will end up doing a lot of things that are completely independent. That means these are, so you are correct. So what he is saying is, just to reiterate the question, that now he is saying that my card payments is dependent on the checkout. I will summarize it in a small statement. Let me know that am I saying it right? In a way, right? So what we had earlier was checkout was including the cash payment. Everything was together. So even if you basically have it in a different implementation or a jar, the dependency was still from checkout on the payment. So anyone who is using the checkout module will end up with a cash payment. That is the first thing. What we did was we made the cash payment or the card payment dependent on the checkout. So now what does that mean is, if I am using a cash payment, I have to use the checkout. Okay, in a way that dependency is there. Now you actually can also make this completely independent. Okay, in a way, there is an example in real life that we can talk about that does it. That is already there in my slides. Okay, so in this case, card payment is actually using the checkout or dependent on the checkout, but you can also make card payment completely independent. In that case, you will need an adapter that actually glues this together. Okay, so in that case, now card payment is completely independent, checkout is completely independent. You need both. So what you do is you end up writing a small adapter that actually glues these two together, and then anyone can use those. So you can make them independent. Okay, so that's where the things is, where what part is reusable is you need to decide. Okay, suddenly you say that my card payment is reusable. Yes. Now you need to start thinking that what else comes with it, and do I actually need it? Okay, so what we flipped here is, I was talking about checkout being the primary reusable component, and card is more like a detail. Okay, I don't need to worry about reusing the card itself. But now we are saying that, let's say if card itself is also a reusable component, then suddenly I have to worry about what it depends on. Does it need to depend on checkout? Maybe, maybe not. So if it is calling something on the checkout, you will use kind of a similar thing. So in this case, let's say card payment needs to talk the receipt generation. That's what you are talking about. I can essentially talk with or use the receipt generation directly, because that's the dependency that allows me to. But I can choose to say that, okay, card payment is highly reusable. I don't want that dependency. I will introduce right interfaces, and now it is going the other way around, but both of them are independent of each other. So interfaces are actually allowing you to break that dependency altogether. Now my card payment need not actually implement or need not access the receipt generation. It is just saying that this is my need. Whoever fulfills it, I don't care. And then you write an adapter that essentially just follow the interface that is used by the card payment, but actually calls the receipt generation. So now your glue code is dependent on both of them, but both the components are independent in themselves. So you need to decide what is reusable. Okay, from a example point of view, I was only focusing on this part of being the usable, but implementation themselves can also be reusable. Okay, so we also did kind of an OCP. Yeah, is there a question?
Cash payment, card payment, these are implementing the payment.
Yes.
But they cannot implement single interface. They need to have separate interface. Payment interface needs to be divided into three different interfaces.
Why?
The card payment does not need UPI ID, right, to process the payment, right?
So you basically use those terms. So you have to get your interface in a way that essentially. So there is a possibility that there might be a payment method that actually ends up asking you to change the interface. That is a possibility. Okay, the moment your interface changes, everything is affected. That's why we are trying to say that your interfaces has to be stable. As long as your contract is stable, okay, you can add more implementations.
Yeah. Contract needs to be like fixed, right?
Yes.
So in this case, it needs to be three different contracts. It cannot have a single contract.
May or may not be. That's what I am trying to say.
Okay.
Completely depends on whether I can. So we haven't defined the contract here. Okay. So you can essentially say that, okay, these are the 2 or 3 things that I need to use. What will be the contract looks like in this case? Yeah. So the question is, so what he is saying is, so the payment interface. Okay, we didn't talk about the specifics of it. It's more like an example in this case. Okay, but what he is talking about is payment interface might not, you might not end up with a payment interface that is good enough that that will serve the need of multiple payments, let's say, and that is very well can be the case. So every time a new new payment method comes in, okay, it might happen. You have 2 things that might happen. One is your interface is good enough, already generic enough, allows you to do the implementation. That's it, you will do the implementation. But you can actually end up with a payment that does not follow the interface or cannot follow the interface. In that case, you have to evolve the interface and you have to say that, okay, is this a category of payments? Do I need a new interface, or can I make this interface itself generic enough to allow this kind of payments in the future? But every time what you are doing is you are making a choice to make it more generic, more abstract. And because you are doing that, you open up an ability to add more payments. So your reason, every change that you are doing in the reusable code base, you actually reduce the reason to change because you are introducing more abstractions. Okay, let me go ahead. Okay, so in a way, the OCP is applied because we are saying that we were able to add the payment implementations without actually making change in the module that we are talking about. So we added more functionality, open for extension, but close for modification. We avoided the modification, though every time, every change might actually break this, depending on your abstraction. But every time is also an opportunity to make your abstraction better. Okay, so every time you do abstraction better, there is a possibility that you end up with good enough abstraction that allows you to take care of all the things that happens in those business. Okay. So abstraction in this case is allowing you to satisfy that opposing need of a reusable code base, reusable module, essentially. Okay, let's move on. So in case of a real life examples, you have things like JPA is one implementation. JPA is a specification. You have a Hibernate as an implementation. So if Hibernate changes, if I am using Hibernate only, I need to worry about it. Otherwise, I don't need to. In case of JDBC, it's essentially there are tons of clients that implement specific communication with the database, but I don't need to worry about because I am only dependent on JDBC. And I can essentially switch from one to the other, and my code base need not change to that extent. Okay, SLF4J is again doing the similar thing. You can use different logging abstractions that are there. So in this case, actually, this is similar to what you were saying. Okay, my payment also need to be reusable and should not depend on the abstraction. In this case, log4j actually do not depend. It precedes SLF4J. So there was no SLF4J. It does not depend on SLF4J at all. So in that case, there is a bridge or an adapter that you need to add that actually bridges the gap. So both of them are independent. Logback, I think, is a native implementation of SLF4J. So you should follow the specification right from this scratch. Okay. Kubernetes. Okay. In a way, in this case, we are not talking about jars anymore, but we are still talking about a contract. If you see all the components that they are now breaking it up, okay, the CNI or CRI or CSI, basically the storage interface. So all of these are, CNI is a network interface, CRI is a runtime interface. So all of these are components. It's like a plugin architecture that you end up in which you are essentially saying that, okay, I own the contract. Okay, contract is part of the reusable code base. Everything else, implementation, is more like a after thing. So you plug in anything you want and you use it. But the main core thing is the Kubernetes in this case. Okay, so where is that? Did I close that up? So as I said that there are multiple principles of the solid. Essentially solid are only 5 of them. I'll zoom it up. So solid essentially are only 5 of them. Okay, you can see that these are the 5 principles, but then there are 6 additional principles which are together said as a package principles. I'm not going to talk about all of them, but together all of this actually is said as a package principles. And 3 of them are coupling principles, and 3 of them are cohesion, and 3 of them are coupling. Okay. In a way, what cohesion essentially is, cohesion principles are talking about are that what should be together. Okay. And coupling principles are talking about is the things you know that are not together. So how do I then depend on each other? So coupling essentially talks about dependencies, and cohesion essentially talks about what goes together. Okay. So in this case, it's not that difficult to understand the principle itself, but you have to think in terms of how do I apply this. So I have just taken one example of it, common closure principle. So if you see common closure principle, it says that anything that changes together is packaged together or kept together. Okay. So classes that change together are packaged together. Now you need to, if you see this comes in different flavors in different places. Okay. So if you actually read about the refactoring chapter 3, the refactoring book, one of the smell called divergent change also talks about something similar. It says that when we make a change, we really want to actually go to one place in the code base, and that's it, make that change there. Only one place. I shouldn't need to go and change n number of places to actually make a change. Okay. In a way, single responsibility also talks about exactly the same thing. So divergent change is similar to single responsibility in that case. That it says that okay, there is one thing that owns that particular thing. I go there and make a change in my system. Okay. So that allows you to say that things that are actually changing together are packaged together. They are kept together. So that way you can go at one place and make that change. And if your cohesion is right, almost anything that is there in that module will actually change. Okay. So in case of a layered architecture, depending on how you are using it, is it at the very high level or is it part of within your modules or low level? In case of a layered architecture, this can be tweaked into saying that there will be one change per layer. Okay. And you will end up with that. Okay. But how will you actually apply this? How will you apply something like a common closure principle? What are the options that we have? Any thoughts on this? So great. We understood that anything that changes together should be kept together. How do I apply this? So you have 2 options to actually go about this. One is you can say that, okay, I will figure out what all things have changed over a period of time. Look at the past and try to figure out, okay, these things are changing together. Maybe I should refactor and essentially group them together. Okay, so these are always changing together and let's keep this together. That is one way of doing it. So you have to do like a Git analysis and a change history analysis to actually come up with the boundaries. But there is one more option that you have, and probably that is a easier as well as more preferred option, is that by looking at the future. Okay, any change that comes in, you analyze and say that, okay, for this particular feature or this particular change, I need to change this place, and this place. Then does this make sense? That should I actually club them together before I make the change and then make the change, so that now I end up all of these are related, that are actually picked up and then moved into a single part of the change. That way I can make a change in future. At least I can make a change at one place in my code base. So you go and basically change one of the modules. So that allows you to club these related things together. It might not be always that seamless. Sometimes it is really that you need to make 2 changes. So it's all basically it's a case by case basis, but at least if you continue to think within your team over a period of time, you will see that the things that actually change together are packaged together. Okay, so that is one way of essentially doing or applying this change. Similarly, you can apply this similar thinking for other principles that are there, like common reuse principle is things that are reused together are also kept together, okay, or packaged together. So you might end up actually reusing them together. So in that case, you essentially figure out what is being reused together and then make the change over a period of time. So in this case, what I'm saying is, it is better to actually approach this iteratively over a period of time and keep on adjusting the boundaries so that you get them right. And then the payoff happens for you. Okay, so let's talk about the couplings as well. Okay, so in case of coupling, even before we talk about the principles themselves, let's talk about the dependencies and how they affect us. So in this case, I have a class A and a class or a module A that depends on module B. Okay, so what is more stable in this? Module A is more stable or module B is more stable? Even without knowing anything inside, what we can talk about? Sorry. So why module B?
Doesn't depend on anything.
So what we are saying here is module B does not really depend on anything else. But by definition, module A actually depends on B. So any changes in B can affect module A. So even if it is highly stable, it can't be stable than module B in a way. Okay, so in this case, the dependency directions will matter for the stability of the code that you have. So in this case, B will be stable than A. A is dependent on B. So any change in B will actually also affect A. Okay, so A can't be stable than B. Okay, what about this? Similar to that, so direction is A is least stable in this case because it will affect, basically it is using B and C, both of them, maybe transitively or maybe directly, but it will be affected. Okay, so the B is dependent on C, so B is essentially less stable than C, but C is the most stable because it only affects, it is not using anything else. So it is everything within the C, that is the only thing that will be there. Okay, so what we have here is, in a way we can say that the fan in and fan out of the modules can actually help us figure out whether those modules are stable enough. Should I actually depend on something on a module that tells us that what else it depends on? Okay, so anything that it depends on actually also make it less stable, because anything that it depends on will change and that will affect the user. So instability can be defined with something like this: fan out versus the divided by the total, basically fan in plus fan out. So fan out is, the more the fan out, more unstable you are. Simple as that. Okay, so more you are dependent on others, more unstable you are. That's what we are essentially saying here. So if you see the principle, one of the principle that says that depends in the direction of the stability, okay, or depend on the modules that are stable than you are. Okay, so that makes sense, because then if you are depend on unstable thing, you always have to deal with the changes that are happening because of that. Okay, so are there any dependency cycles in this? So cycles makes everything worse. So there is also a principle around that. Is there a dependency cycle in this? There is no dependency cycle, because you can see that dependencies are only flowing down. They are not going up. Okay, and that you will see in almost every tool that you use for this kind of analysis, that's how they depict the dependency graphs. If the things are going down, that's great. Okay, now in this case, what I did is we are saying now D actually depends on A, which is the worst thing to actually do. Okay? If you end up doing this, so let's say these are not modules. In case of a module, proper modules, your modular system will not allow you to actually do this. But let's say these are just classes or packages in your code base. Okay, if these are packages in your code base, the moment you add this call, nobody is stopping you from adding this call because it's all packaged together. So even if there are different packages, if I add this call, now I have made it very hard to actually decompose the system. Okay, now it will become difficult to actually break this system into modules later on, because the dependency direction is essentially everything is dependent on everything. So how do I break this up? And that's where the breaking up modules and things will come in. Okay, so we are going to talk about, we are going to see how can we use certain tools to actually do the dependency breakage. So dependency cycle prevents module creation because everything depends on everything else. Okay, in general, if you are already modularized, then this will not work in the first place. So, so if you are using Maven or Gradle, it will not compile essentially. Okay, Java 9 modules, all those things will not work. Okay. So again, so if you have something complex like this, you can still figure out that is this a good dependency or a bad dependency. So in this case, E and F essentially uses almost anything that is there. Okay, A depends on B is a bad dependency because B in turn depends on a lot of things. If you break that up, A is very stable. Okay, but because A started using B for whatever reason, B in turn is using some other things. It's basically a dependency on a wrong direction. So you can do this kind of analysis. There are tools as well, like JDepend is there, which can actually do this kind of a package dependency analysis and tells you that where these are within a module. Sometimes it's fine. Okay, across the modules, when you want to break them up, these dependencies will actually make things difficult. Okay, it will make things unstable, either unstable or make it difficult to actually break things apart. Okay, so in general, the dependency graph is depicted like this. Dependency flows down, as I already said. Okay. So dependency direction. So generally at the bottom of the graph, you keep things that are stable, because things are flowing down. The dependency direction is flowing down. The bottom part, bottom modules or classes are stable. Okay, those are the most, those are the ones that are used the most. Okay, and generally you don't want cycles. Okay, so something like this. At the very top, you have concrete things like factories or dependency inversion things. These are very concrete because they need to deal with creation or things like that. So you can't talk in abstraction. You have to create card payment, let's say. So then you have to know about card payment. Okay, things like that. Okay, or the end of the thing, because these things essentially use everything that is abstract. On the very bottom, you have things that are abstract, like the checkout module that we talked about. It's not completely abstract, but the payment is not part of it. So the abstraction is there. Or the switch, in which it just depends on the interface. So that's abstraction comes in. So over a period of time, you will get the abstraction right to make it keep on reusing. Okay, and you should be able to change or make it work in different scenarios just by adding up the right implementations or right dependencies and then use it in different scenarios. Okay, so that's where the reusable code, reusable models will essentially are at the bottom. Okay, and we are saying that this can change frequently because you will keep on changing. That's the primary way of making the change, and these should change rarely. And every change that you do, you take it as an opportunity to actually make that change irrelevant in future. Okay, so if you follow this, you will end up with a code base where majority of there will be parts of your code base which almost never changes or infrequently changes, and then there will be part of the code base which will change frequently. But those will be like a change in which you essentially do wiring and all that thing. And also new features or new things that does not even exist in the code, most likely you will add them as a new code rather than changing in the existing one. Okay, so that's where this will actually take your code base to. Okay. Okay, so we have an example, a kind of an example, because I wanted to show something, not just talk about, but show something real or concrete that you can actually go and try to see, open up your code bases and actually see where all these things are happening. And then sometimes you will end up with surprises that you might not expect. You might not expect that this thing actually talks with this thing. Okay, and then how do I actually break it up? So I'm just using a sample code base. It is big enough for us to see certain patterns or certain things, some complexity. But at the same time, to be honest, I haven't worked on it. It's just a code base, but I just wanted to have a real something that allowed us to see at least what are there, and then we'll try to do some sample changes to break things up. Those might not be the very correct thing in this domain, okay, but still it is a good thing to actually do that so that we can see how to actually use it. Okay, so this is a sample application. What it does is it's like an orchestration of a kind. So what it does, it takes like a DAG or a graph, a dependency graph, and every node represents some task to be done in certain order. So they have a dependency. Some of them can happen in parallel, some of them are interdependent on each other and all that. Okay, so it is essentially, so DAG is in a way is an input, and then it executes that thing, and it can be communicating to a service or something like that. So it makes a REST call or API call, or it can be a asynchronous call. So it is essentially sends a message to something or something like that. Okay, so that's the code base. You don't need to understand a lot. We can just try to infer certain things and say that, okay, this probably doesn't make much of a sense. Or we just open up and say that, okay, this direction does not make sense. Let's try to break it up. Okay. Okay, so for this, I am using IntelliJ IDEA DSM. So there is a tool that is part of the IntelliJ IDEA. Okay, I have a license. You should be able to use it, open it up, and see that can you actually visualize the dependencies in your code bases. Okay, so this is the code that is there. Let me open up the DSM for this. Let me know once it is visible. Huh? It's visible, right? I can't zoom more than that.
Yes,
So,
it's visible.
yeah. So in this case, as you can see that it is laid out all the packages that are there in the code. Okay, so let's see what it is actually trying to show us. So as I said, the dependency graph, the things at the bottom are the ones that are supposed to be more stable. That means they will have more incoming dependencies rather than the outgoing one. That means they are more stable. They are serving others, so they have to be more stable. Okay, the things that are at the top are essentially the one that are calling those components. Okay, so that means anything that goes from bottom to up is a wrong direction. Okay, any dependency that goes from lower things to the top is a kind of a questionable direction. Not everything in this case, obviously, it is laid down one after the other. So they might actually have same or similar weight. Okay, so it's not essentially exactly the same, but you can essentially question because you also have a knowledge of the code base. You understand the domain, then you should be able to question that does this dependency actually make sense, or how do I actually break this up so that I can end up with a module that I want to actually extract out of this code base. Okay. Apart from this, this is also showing you cycles. Okay. So there is a round thing that actually shows cycles. Okay. Then so the layout is things that are at the bottom is highly reused, things at the top is less reused, that are the one that are using the downwards. Then these numbers essentially talks about how many times how many dependencies are there. Okay, so if I let's say click on the utils class or utils package, what it is telling me is, though there are numbers like 6, 42, 10 and all this. Okay, so if you hover on 6, what it is saying is 6 essentially are the incoming dependencies on utils class coming from the controller. So if you actually go here and say that okay, this is the controller, so till the dash, I'm not sure whether you can see the dash, but there is a dash at the as part of on the diagonal. Okay, so if you go straight up and see that okay, this is the controller is calling utils 6 times. Okay, similarly if you see this, dal is essentially calling utils 42 times. So classes inside dal package is calling utils classes these many times. Okay, similar, so this is horizontal. Okay, horizontal is things that are incoming. Okay, other parts of the system is calling you. Okay, then there is a vertical line as well. Okay, this is where you are calling the other things. So this is outgoing. So vertical is outgoing, horizontal is incoming calls or incoming dependency. So in this case, what you are saying is utils essentially calls which one is this thing? Controller component 16 times. Okay, so it is calling certain packages or classes in that those many times. Okay, then it is also calling domain 65 times, which is kind of weird. So utils is calling domain. Why? Okay, and that's where the kind of a questioning comes in, that why util need to call the domain or other way around. The domain can call the utils, but then there might be some use cases that you might end up saying, okay, this needs to be there. And if you end up within, so if the problems comes is if these ends up on 2 different modules. Okay, if one is on the another module, and so if you are crossing the module boundary, then only it actually is a problem for you to break the dependency. If you are saying this is within the module, you can still tolerate the directions of those dependencies. Okay. Okay. So in this case, okay, let's talk about the what do you say, the cycle as well. So in this case, the cycle is essentially utils util calls the component. So these are the 16 times it is calling. Okay. Also, you can see that there is at the very top on the right hand side, it shows different color codes. Okay, so it says that blue is dependencies, then red is cycles. Okay, then green essentially is the usage, which goes till the blue, till the yellow. Okay, so in this case, utils is calling these things or some of these things. So these are the usages, and then other way around. Okay, so in this case, it is calling the other things. Okay, so let's open it up and see. So let's actually see that what is this cycle about? Where is this cycle exist? Okay, so if I open this up now, after opening up, the cycle might not actually exist. Okay, there is a possibility that once you open it up, there is a possibility that cycle might go away, but the calling still remains. So at the package level, cycle exists. At once you expand it up, not exactly the same classes are calling each other. Okay, so once you break it up, collapse it into a package level, you might end up with a dependent the cycle essentially. So now in this case, what we are saying is, so component, okay, so there are two things that are calling the components. Okay, so everything that is green is essentially the entire package that is selected. The util is still selected. So that's why you see the area, the horizontal and vertical area. So it's not one line anymore. It is all the classes it is showing. Okay. So in this case, there are 12 calls from test, the security util test to component, and then there are 12 calls from security utils to the 4 calls from security utils to the component. So I'm not going to bother about the test class, but let's see the utils class. Or maybe there are others as well. Let me check. I think there is a domain dependency as well, right? There is a domain dependency as well. So there is a cycle between utils and domain as well. Let's check that up. So in case of this, if I expand utils, domain also has things like security util test and the security util. And then there is a web clients util. Okay, so web clients util is actually using domains. So this is incoming. These are basically where the cycle is. So 14, because it's red, that's where the cycle is. So let's open up that web client utils. So if you just select this, it is showing that it has a call with the domain 14 times. Okay, and you can also see a red dot here that shows that there is a call. So now if I expand this, it's now shifts to node handlers. So within the domain, I'm calling something within node handler essentially. And if I expand it further, now the cycle goes away, but there is still a call. That means I'm essentially calling these 3 things. Okay. So what am I calling is HTTP security, not this. HTTP security details, API key security details, and basic auth security details. Those are 3 classes that I am calling from utils within the domain. Okay. Let's say that we want to break this up as an example. Okay, so let's actually open up the web client utils. So you say open it up. So this is the web client util, and there should be these 3 classes. Okay, so domain, node, handler. Is my code visible? Should I zoom it? Increase the font. This should work, no? Is this better or even more?
It's readable, that's fine.
It's readable. Okay. So these are the 3 classes. That's where we spot the dependence. Let's see where they are used. Okay, so they are used here. So there is something called as add security detail, which in turn is doing some instance of on these things. Then it is getting something from the basic auth, username and password, and then it adds it into the request header as a basic auth thing, which makes sense. Okay, similarly, what you are doing is you are adding a header. In case of API security, you are using a token essentially, I assume, and then you are adding certain headers as part of that security thing. So in both the cases, what we are essentially doing is adding a security details, the right headers in the request. Okay, but one thing here is, can you comment anything on this? Is there a principle that is violated here? One of the solid principles. Sorry?
Yes, sir. Single responsibility.
Single responsibility. Single responsibility in utils, there is no single responsibility. Yeah. So utils in a way is like a dumping ground. You don't know where to put this, you just put it there. So single responsibility can't be argued almost everywhere. Is there anything more specific than that? So-
Difference and comparison of the instance. It's breaking the principle of doing one thing. A function should do one thing.
That's what he is saying, single responsibility.
Then the difference is.
Okay, so more specific is something like a Liskov substitution principle. So what is happening here is, one thing is, this code very much understands or knows that there are subclasses in this, and it knows the subclass. So it's directly coupled with the subclasses. If it is part of the module, you already lost the module boundary. Okay, if it is outside, then that's fine. Okay, second problem with this is why it probably is a violation of Liskov substitution is there is always a possibility of one more if. Okay, so if I add one more implementation of the security details thing, then one more the HTTP security details thing, I will have to come here and add one more thing. Okay, so I am coupled to not just some implementation, I am coupled to all of them. Okay, that means this code can't be OCP compliant because I already know not just the abstraction but all the implementations of the code base. That's where the risk of substitution essentially comes in, that my component is now needs to know the implementations. Okay, if it is outside of the module boundaries, this code is fine. If it is inside, then you are coupled with, so there is no boundary essentially. So your DIP is broken. You are dependent on the subtypes. Okay, let's see what we can do about this. Okay, so if we are saying that in a way we can actually push this as a part of the interface itself, it need not actually be in the util class. So what is actually doing is something like this. Okay, so if I say so I will give exactly the same thing. So I just did a extract method. Okay, and I'm just giving the name for the new method. So it is exactly doing the same thing. Security, add security details, and that's what the name suggests here. I'm just using the same name. Okay, so in this case you end up with add security details. Now my good thing is idea actually use the more specific type rather than a so I don't need to do instance of here. There is an instance of, but I don't need any cast or anything here. Okay, because my type input type itself is now this specific implementation. Okay, great. So if you see or if you see this first parameter actually gives us a hint that this code probably actually depends on or belongs to this class. Okay, because it is very much about this class. It is doing something with this and plus adding a request header and doing something like that. Okay, so in a way it is itself is giving us the hint that it probably belongs to basic auth security in the first place. It should not be here. Okay, and if you see, idea is smart enough to actually give us the hint as well. So if I say convert this to instance method, okay, it is actually telling me that should I move it into basic auth implementation. So it also understands that it probably belongs there because that's what you are using. So the function should reside on the classes which they are using the data of. That's the basic object-oriented principle, encapsulation. Your functionality should belong to the class where the data is. Okay, and that's what your ID is also telling us. Okay, so if I essentially say, okay, do this, okay, that means this class now will, this function now will move in this, and okay, and you can see that the implementation is actually changed, in which we are now just calling that add security details. In a way, I can do this same thing for the API security details as well. So let's quickly do that. Add security details. Okay, and I will do the same refactoring here as well. So again, these are case to case basis. Okay, you will not end up using exactly the same steps, but at least you are getting an idea of decoupling between domain and a util classes. That's what we are doing. Okay, so those two are gone. Now both of them are essentially there. Now if you see, they almost do the exact same thing. The only flavor is that they belong to a different class, but I don't really need to worry about. If you see the implementation of this, okay, if you go to HTTP security details, it says that I have exactly 2 implementations, not more than that. Okay, if I have only 2 implementations, both of them are here. Okay, that means I don't need any instance of or anything like that, as long as this security thing actually exists on the base class. Okay, that means the interface. So if I actually move this into the interface, then I don't need to actually do anything related to instance of or anything like that, because this belongs to both the flavors of the implementation. Okay, that means now I can come here, do a refactoring, say that pull the member up. Okay, and then it shows me that okay, this is the member. It also already knows that where to put that in because of the inheritance. So I say that okay, refactor this. Now you can see that this is marked as override. Okay. And if I go to the security details thing, it shows that a method is added with this exact signature. Okay. The moment I do this, and I'm hoping that even API should actually do this. Why it's not doing it? Okay, it is doing it, but it doesn't show the override. Okay, so it is actually doing that, but it doesn't show the override. It didn't add the override, that's all. Okay, so both of them are actually now doing 2 implementation. It's already understood that there are 2 implementations. So now if I go back, I don't need this type check anymore. So I can essentially just do remove redundant cast, remove redundant cast. In fact, I don't need any checks here. So I can essentially just do this. Or is it allowing me to do that out of the box? No, probably too much expectations from the ID. Okay, so I can actually get rid of all of this. Of course, in this refactoring, you will need good test. You will need everything. So I'm like asterisk there. Okay. Okay. So now what we end up doing is we are essentially did this. Okay. I don't need this variable. I can essentially just do this as well. Okay, we are still coupled with the, so we removed the dependency of 2 things. So you can see that these 2 are not anymore there. So at least half of the things gone, but there is still one, that is HTTP security data, that still exists there. Okay, so what do I do about that? Any suggestions?
Static method is not needed.
Sorry.
Static method is not needed.
So what do I do with it? I can essentially say inline this method. Okay, inline and remove, because I already add security in the interface. Okay, so and both the implementations are already there. So I don't need this util guide, just calling the same implementation. So I can basically say just use the implementation. I don't need this util method at all. So I can say refactor and that's it, it's gone. So now even this, okay, so there are more dependencies on this, but at least we showed a kind of a example in which you end up removing entire things out of this. Let's go back to the DSM. So you will have to do similar things for the other dependencies that are there. there are other kinds of things as well in this. So if you see domain, okay, domain in a way is dependent on configuration. Okay, which is also kind of weird because configuration seems like very end of the thing, very specific. Okay, you are getting configuration from a file or some very specific implementation thing. Domain might be very abstract or very specific to the domain of your system essentially. So why it is coupled to configuration is kind of a questionable thing. So you can actually figure out and see that where are we calling this. So you can see that it's calling this node handler is calling configuration. So node handler, where are we calling node handler? So this is test HTTP external node handler. Okay, and then there are one more gRPC external node handler. Okay, and then there is a test. So if I go to HTTP extension node handler, where is that? This one. This guy is calling configuration these many times. Okay, what is that it is exactly calling in this? It is calling application properties, which is very specific. Why do I need to, why my module or domain need to couple with the application property, which might actually be picked up from a file? Okay, I should be able to support multiple of them. Okay, so I might actually get my application properties from database or maybe from a config service or something like that. Okay, so if I break this up, I will get that benefit. So if I actually open this up, let's see whether we can do that. Okay, so where are we using this? Application properties. Okay, so it is doing application properties. Where are we using it? Okay, so we are using application properties here. Okay, what it is doing is saying that give me a property called default timeout, HTTP default timeout, and we are passing int and all these things. Okay, what do you think we should do as part of it? How do I remove the need of a application thing? Any suggestions? So what generally, yeah, any suggestion? No. So what generally happens is the way you can sometimes or most of the times you can actually decouple this is by introducing or moving things out. Okay. So now in this case, what I actually need, I don't really need application properties as such. What I actually need is that HTTP timeout. Okay, so as long as you give me HTTP timeout, I don't care whether you are getting it from application properties or something else. Okay, that means I should be able to just pick this thing and say that move this into a parameter. Okay, just take it as a parameter and you figure it out how to pass that in. Okay, so that means if I say this, so I introduce a parameter in that method and I say that this is HTTP default timeout. Okay, so that's the integer. Okay, does that remove, what does that remove? So this is definitely a private method. Okay, so there must be a call here. So this is the call for that method. Okay, so we just moved it from this to this essentially. Okay, we need to do more. So let's do the same. But now, okay. So handle is a public method. Okay, so you can go ahead and do it if you are okay with it, because in this case I think it's a okay change to do. But at the same time, it's not just a public method, it's also a part of a interface, it seems, because it's doing a override. Okay, so it is definitely a part of an interface. So what can we do now? If we do a extract as a parameter again, it will change the interface. Okay, but we have one more option. what we can do is we can actually not introduce a parameter, but introduce a field. Okay. So that means it will only remain in the implementation, this class, but not become part of the interface. Okay. Because this is a construction thing. We can basically say that this guy needs it, but interface doesn't need it. Okay. That's what clearly is being shown, because interface doesn't need this thing. So that means I can actually introduce a field called HTTP default timeout. Okay. So that field is added somewhere here. So you can see that the field is added, and that field is basically getting the from the application properties. Okay. But now you can see that now idea itself is saying that you don't really need application properties anymore. Okay. That means I can actually get rid of, it says convert this to the local variable. That means I don't need it to be a parameter, the field anymore. Okay. So that is good, but I'm still using it here. Okay. I'm still using it here. Okay. That means now I can, what can I do? Same thing. I can essentially do the same thing. I can say that, okay, I don't care where you are giving it from, just give me as a parameter. Okay. So we basically moved entire thing out into the caller. Okay. And then here it is given a weird name. So let's fix that as well. Okay. So now I think there shouldn't be any need for that config thing here. Okay. So entire thing is moved out. So these are some techniques that you can use. Parameterization or introduction of these things is quite common. Another thing that are common is like move classes. Okay. Segregating what? Yes. So basically what we are saying is, so the question is asking is, can we use DSM for segregating or separating the modules, the code base into basically multiple modules? So the thing is, yes, that's what we are basically saying, that if you end up figuring out that probably this is a module boundary, the first thing you need to do is break up all the dependencies, and that's where the DSM will come in and allows you to break up all these dependencies. So that's what I was so if you basically say that, okay, domain should not depend on component or config, then we end up breaking it up and say my domain is now independent of this, and then maybe I can create a module out of it. Okay.
Can you take an example? In the DSM, like say that this model, this package is independent, and maybe not.
It's in a small code base, maybe I could have, but in this case, it will take too much time to actually break it.
Identify that, okay, this package, particular package.
So you can see that in the DSM, if you open up DSM again, let me open it up. Analysis. It doesn't give you a package boundary. It doesn't give you that. What it gives you is where is the coupling, or what all things you need to break up to actually do that. So for example, as I said that, let's say we said that domain is something that we want to separate out, and maybe with the domain, there are certain things that might go. Let's say util is part of the domain. Okay, so I don't need to worry about breaking up domain and utils. But as I showed that, I don't want domain to be dependent on configuration. Okay, so at least I break up domain dependency on configuration. Okay, it is still dependent, but we have broke something. Okay, let's say that is the only dependency. Now I suddenly end up with a domain that is not dependent on config. It's the other way around, or maybe other way around. Okay.
Filter package, good example, but maybe it doesn't depend on anything. What we see, and you can convert it to a format.
Yes. Yes.
Like the way.
So the moment you need to say that, okay, these are the things I need to move into a module, then you will have to actually put the kind of a periphery around it. It can't depend on anything else. Okay, people will use it, so you can call the module, but module won't be able to call you. Okay, because that's like a given thing. That's what we are trying to achieve. Okay, so that means once you do that, then you have to break the module boundary. Once you break it, then you can move it directly. It's like just a move. You just create a domain, the module, and then move the code. Okay, and because it's all within, it should be straightforward in that regard. Okay, so coming back. Okay, so move classes, like very straightforward thing. In this case, module A, module B. So class, in this case, these are like calling each other. Okay, so if I just move one of the class on A, so you can see that the dependency is now within, and only A depends on B, but B doesn't depend on A. That means now I can actually pick this thing, move it into a module, and that's it. It's like solidified. Now my compilation itself will not allow me to actually have a other way around dependency. Another option is DIP. DIP is the very strong thing that you can actually do to decouple things. Okay, like what we did till now. So if B is calling A, okay, and A is calling B, in this case I can say, okay, I don't need to call A anymore. So like payment, if I'm calling cash payment, I don't need to call cash payment. I can say that, okay, cash payment implement me, rather than I'm calling cash payment. So I don't need to do that. I can basically introduce a payment interface, and I don't need to know whether cash payment even exists. Now cash payment has to call me, or you need to write a glue code that actually calls each of, basically glues them together, like a bridge or adapter. Okay, so in this case, what you did is you added an interface. Interface is any method that you are calling on classes in A. So you added an interface. The interface is part of B. Okay, and then A is implementing that interface. That means now A depends on B, but not the other way around. Okay, so you can see that both the dependencies are coming in. So A depends on B, but B doesn't depend on A. So dependency inversion can be used for breaking up this kind of thing. Then once you all do that, if it is in a fuzzy or a limbo kind of a thing, you haven't figured out the modules yet, and you still want to mark things within the same kind of a thing, there are frameworks that actually allows you to write tests, which makes it easier to control the dependencies. Okay, I think this is probably the last slide, so I don't have anything much after this. Yeah. Okay, so okay, so there is something called as an arch unit. As the name suggests, it's a architecture unit test essentially. So it's not like a normal unit test that you write. It's very specific for the architecture or the dependencies and all that. So in this case, if you go to, let's say, the user guide, you can see a lot of interesting things here. Okay, like class dependency checks and all that. You can say that layer checks are there. So you can essentially add checks or a test on the layers and only allow. So in this case, it's saying that the services should not call controller. Okay. So this access goes against the layer. But the green ones are allowed. Persistent should not call this. So if you have this kind of a thing, you can actually add a test like this and say that, okay, controller may not be accessible by any layer and all that things. Okay, so that's what you are essentially writing a test. Then there are other things like cycle checks. You can do this, but once you do modules, okay, then these are better boundaries, because by definition you can't have cycles if you have created proper physical modules. Okay, but if you haven't essentially decided yet and still want to control something, then this is a good option that you have. In this case, you are saying that I don't want any cycle, so this is allowed, but this is not allowed. So this thing should actually fail. This is a test that says that packages that are classes that are within this should be free of cycles. Okay, so it will check that cycles and then basically flag it whenever you make a change. So it's not only about making the change one time, but you have to also preserve the architecture, and that's where this kind of a test will comes in. Okay, so just to conclude on this, the entire thing, what we talked about is, we talked about reusable module, what are the properties, how can you achieve something that is reusable. So if you have right amount of abstraction, you basically should be able to use that and still have a stable reusable code and change things from outside without actually changing the code, at least those part of a thing. Then you might end up like he was saying, that the implementation itself is also reusable. So then you have to guard that as well, because now you are using it at multiple places. Okay, so then in that case, then you have to think that, okay, my implementation also need not or should not depend on unnecessary things. So how do I guard it? Okay, so that whatever is reusable that you think should be guarded in a way that so that you can depend on it and still allow to change it over a period of time. So you need that balancing act essentially. Other thing is, a lot of this that we talked about is that just a tooling or a path. Okay, you still need to make decisions. There is no silver bullet. Whenever, even if you end up with modules, okay, your boundaries might not feel right or might not be right, or let's say they are right, okay, but your domain or a business requirements will take you in a direction that they are completely mismatched now. So every new requirement can actually challenge the existing architecture. Even if existing architecture is perfect, it won't be perfect in the face of the new requirement. That means you have to keep on fiddling, keep on changing things, and that's how it is. So there is no silver bullet, but it's still a path to actually take you to a code base that gives you certain part of the code base that are stable, and then certain parts that you can just change or configure or write new code rather than changing the existing one. So get a stable thing. So there, yeah, that's the conclusion. Any questions or anything? So these are the references that I've used. You can explore, a lot of details are there on these things. Okay, essentially the first one, the software development principal patterns. This is where the solid was first time added as a, I think, as part of a book essentially, and then package principles and everything is also there. Clean architecture goes in much more detail in those as well. It adds a lot of new things as well because of the changes that has happened over a period of time, because the first one is quite old. Then refactoring, improving the design, the language is different, but you will see certain things that are talking about very similar things. Okay, like I said, that it says the divergent change or shotgun surgery, which are like weird names, but they actually map to single responsibility, or they map to like a common closure principle, and then they give you those hints. So once you know this, now you can actually connect those dots and say, okay, this is what they are talking about. Then evolutionary architecture goes a lot in modules as well as microservices, as well as like fitness functions and a lot of things that are there. That's also a good reference. Any questions?
Just to add one point, like we were extracting the interface method, and eventually you also added a dependency on that interface. So you should also be aware of that while reducing dependencies, then some extra dependency might get added. When we added a new method in that HTTP interface, right? New
Yes.
dependency came up,
Yes.
request object. So maybe we should be more aware, but what gets added when we are doing something.
Yes.
Maybe there is a better way. What will that is get added? That might
Yeah. So one point of the interfaces, and that's why I talked about ISP, is that your interfaces should be, ideally your interfaces will be should be very stable. The moment they change, everything else change, because they are the contract. Okay, it's like a contract. The moment you change the contract, everyone is affected, whoever is dependent on that contract. Implementation as well as clients. Okay, so interfaces should be stable enough. Okay, having said that, you will need some changes to get it right over a period of time. That's why segregated interfaces make sense, because you end up adding only those things which are required by the client, not worried about the dependency, the implementations. So implementation might need something, you will not add that in the interface, because implementation it's not dependent on the implementation. Okay, so it's basically you ends up with a smaller interface that only has things that are required by the client rather than the implementation, and then the implementation can choose to implement whatever is there. That's the, so if you see the real life example that we talked about, they're exactly doing that. The interface is controlled by the main component, but these are just the implementations of those. Any plugin architecture actually does it like that. The interface is part of the contract and the implementation is just a plugin. Any other questions? Is there a question on chat? Yeah, nothing, right? So yeah, that's it from my side. So even if you have any other questions later, you can ask on the community. Ask on the community and all. Yeah. Thank you. I will stop sharing.